Hello everyone, welcome to Piezo Physics. In this particular video series, we are going to learn about four fundamentals which are trigonometry, vector calculus, integration and differentiation. These are the main mathematical techniques which you need to solve any kind of physics problems. Okay, so first topic which is going to be trigonometry. I am going to make 2 to 3 videos on trigonometry which will touch every kind of concept of trigonometry which you need to learn about, and you will apply these concepts when you are going to solve some problems. Okay, so first of all, before starting trigonometry, we should know what is angle. So just let us see what is angle. Consider one horizontal line here. If we rotate this horizontal line by some angle like this, okay, so this is the rotation. Okay, so measurement of this rotation is known as angle, and it has two units. One is degree and second is radian. Okay, so generally degree has symbol of this small circle and radian has unit of radian. Okay, so generally this angle is also known as plane angle. So now let us see some few angles. Okay, so if we have two lines like this, these are known as parallel lines, and it has angle theta equals to 0 degree. So if we have one line like this and another line is like this, so these both the lines are anti-parallel, and here theta is taken as 180 degree. Okay, and third angle can be shown as like this. We have one line here and another line is generally here. So you can tell this both the lines are at 90-degree angle. Okay, and this is known as right angle. Okay, so these are few angles which you need to know. Okay, so now degree unit is like here 1 degree can be divided further into minutes, which is like here 60 minutes. Okay, again now we divide minutes into seconds, so this single dash is known as minute. Okay, so if we divide 1 degree measurement into 60 equal divisions, that will be known as 60 minutes. Okay, now let us see 1 minute equals to how much seconds. So this will be 60 seconds. Okay, and 1 degree, therefore it will be equals to 3600 seconds. Okay, so this is all about like degree and radian. Now let us see what is the relation between degree and radian. So our new unit system, which is radian unit system, which can be defined as, okay, so consider this circle. Here we have center of the circle, and I can make one horizontal line here. Okay, so if we rotate this line by this much angle, okay, so this angle will be 360 degree. Okay, and consider this radius as r. Okay, so generally what is angle? Angle equals to, we have arc upon radius. So if I rotate this line by 360 degree angle, okay, so it will complete one full circle. Okay, and now we know that the arc will be 2 pi r for the one complete rotation. Okay, so I can put r equals to, arc equals to 2 pi r, and we know the radius is r. Okay, and angle created will be 360 degree. Okay, so now let us cancel this r by r. Okay, so we have 360 degree equals to 2 pi radian. So generally radian unit is measured in multiple of pi. This multiple can be integer or fractional integer. Okay, so now we have 360 degree equals to 2 pi radian. Now if we divide this degree into half, okay, so we will have 180 degree equals to pi radian, right? So now 1 degree will be equals to pi upon 180 radian, and here we can say that 1 radian will be equals to 180 upon pi degree. Okay, if we divide 180 to the pi, so generally we can take the value of pi equals to 3.14, so we will get here 57.3 degree. Okay, so these are the few numbers which you need to remember. Okay, so basically I just remember this one, 180 degree equals to pi radian. Okay, so if we have two anti-parallel lines, so this angle will be pi radian. If we have two parallel lines, so this angle will be 0 radian. Okay, and if we have two horizontal lines, so this angle is 90 degree, which is basically pi by 2 radian. So now let us see how to convert degree to radian. Now let us look into some examples of in which we will convert degree to radian. Okay, so 180 degree equals to pi radian. This is we know. Okay, so first angle will be our 0 degree. So 0 degree will be equals to 0 radian. Second angle we can take is 30 degree. Okay, so in this case what we can do, if we have 180 degree equals to pi radian, then 30 degree will be equals to how much radian? Okay, so by cross multiplying we will have 30 into pi divided by 180. So we will get 30 divided by 180 will be 6, so it will be pi by 6 radian. A third example is consider 45 degree angle. Okay, so 45 degree angle can be converted into, like, now we can directly multiply 45 with the pi upon 180. So this is the shortest method in which you can directly find uh, the parameter into radian. Okay, so 45 same 180, so 45 can cancel 180 at 4, so it will be pi by 4 radian. Okay, our fourth example is 60 degree. Okay, we can multiply simply 60 with the pi upon 180, so this will be, now we can cancel 60 with the, now we can cancel 180 with the 60 at 3, so this will be pi by 3 radian. Okay, uh, after that we can have one another angle which is 90 degree, or fifth example. So 90 degree will be converted into 90 into pi upon 180. So 190 can count 180 at 2, so we will have pi by 2 radian. Okay, so these are the few examples in which we can convert angle if it is given in degree to the radian. Okay, so this is like simple formula. Okay, uh, remember this thing and you can apply unitary method. Okay, so I can take any random example in which I am going to convert to the radian. Okay, so consider one angle which is 135 degree. Okay, so what I have to do is simply 180 degree is equals to pi radian, and 135 degree will be equals to how much radian. Okay, so just we will have 135 into pi divided by 180. Okay, so 135 can be cancelled at 3 and this will be cancelled at 4. We will have 3 by pi by 4 radian. So this is what we can do while converting angle which is given in degree to the radian. Now let us have some convention in which the angle can be taken as positive and negative. Okay, so our reference axis will be always x-axis. So if we measure the angle in the So if we measure the angle in the anti-clockwise direction, this will be taken as positive always. Okay, so this is anti-clockwise direction. This will be taken always positive. Okay, uh, in clockwise direction, if I take one rotation here, okay, so this rotation is in the clockwise direction. This will be taken always negative. Okay, so always remember, we generally measure the angle in the anti-clockwise direction, and which will be taken as positive. Okay, so consider if we have angle theta here, so this will be positive. This is theta. Okay, so this will be taken always negative. Okay, so now you can clearly see this angle is measured in the clockwise direction and this angle is measured in the anti-clockwise direction. That's why it is positive and this angle is negative. Okay, okay, so now we have few examples in which we will convert following values of degree into radian. Okay, so our first angle is 45 degree. So how to convert 45 degree into radian? We had 180 degree equals to pi radian. So 45 degree will be equals to how much radian? So we can simply say 45 into pi upon 180. So 45 can cut 180 at 4. So we will have pi by 4 radian. Or second example, which can be taken more than 90 degree angle. So let us take 120 degree. Okay, so 120 degree. Now let us convert 180 degree. We have pi radian. So 120 degree will be equals to how much radian? Okay, so 120 into pi upon 180. So this will be basically 2 pi by 3 radian. So our third example is which is more than 180 degree. We can take this example as 225 degree. Okay, so we have 180 degree to pi radian. So 225 degree will be equal to how much radian? Okay, so we can clearly put 225 into pi divided by 180. So 225, you can clearly see this will be 45 into 5. This will be 45 into 4. So we will have 5 pi by 4 radian. Okay. Our fourth example is which is more than 270 degree. Let us take this example as 330 degree. Okay. So we have 180 degree equals to pi radian. Then 330 degree will be equal to how much radian? Okay. So 330 into pi divided by 180. Okay. So we can clearly see this is 11 into 30 and this is 6 into 30. Okay, so we will have 11 pi by 6 radian. So these are the few examples in which we can learn how to convert the values of degree into radian. Okay, now let us calculate few examples in which we will convert radian values into degree. Okay, so our first example is pi by 3 radian. Okay, so we have pi radian equals to 180 degree, then pi by 3 radian equals to how much degree? Okay, so just multiply it in a cross multiplication. Okay, so pi by 3 into 180 divided by pi. Pi will cut pi and 180 degree upon 3 will be equals to 3 degree. So second example is pi by 2 radian. So this will be equals to pi radian equals to 180 degree and pi by 2 radian equals to how much degree? So we will have pi by 2 into 180 upon pi. So pi will cut pi and 180 degree upon pi 2 will be equals to 90 degree. Or third example is convert 2 pi by 3 radian into degree. So we have pi radian equals to 180 degree, then 2 pi by 3 radian equals to degree. Okay, so we have 2 pi by 3 into 180 upon pi. Now let us cancel pi to pi, and 3 can cut 180 at 60, and 2 into 60 will be 120 degree. Okay, so these are the few examples in which we can convert radian into degree. Okay, so the summary of the video can be taken as, okay, so we have 180 degree equals to pi radian, then 1 radian is greater than 1 degree. This you have to clearly remember. Okay, and generally 1 radian is equals to 57.3 degree. Okay, so these are the few things which you need to clearly remember. Okay, and apart from that, we will see now how trigonometric functions will work, and what will be the values of trigonometric functions and all these things, and we will remember some trigonometric identities. So see you in the next video. Thank you.